This is another 2023 number challenge. Here we have an equation. Of course, all the numbers are integers. And here we try to find the smallest integer n. Now notice that if you multiply the denominators by a constant, the equation still holds. For that reason, we assume that x, y, z are pairwise coprime, no common factors. And n and 2023 is coprime. Notice that 2023 is factors 7 and 17. So here we assume n is coprime with 2023. And also notice that xyz could be symmetric. That is, if you exchange xy or yz for that matter, the equation still holds. So it is okay to assume x is smallest, z is largest, and they do not equal to each other because they are coprime. Alright, so how shall we go about solving this problem? Of course, the first step you want to do is to turn this equation by get rid of the fraction, right? So that is equivalent algebra here. And of course, let's express n. Notice that xyz and xy plus yz plus zx, we claim that they are coprime because xyz are pairwise coprime. Okay, so why is that the case? We can prove it by contradiction. For example, assume they're not coprime. That is, there must be some prime number p that is common factor of both. Right? So let's assume that. Let's do the proof by contradiction. Assume p divides both xyz and xy plus yz plus zx. Now, from the fundamental property of a prime number, so in this case, p must divide either x or y or z. So in this case, without loss of generality, so we can assume p divides x, right? So in that case, if that is the case, notice that p also divides xy and zx, and then it means p has to divide the remaining one, which is yz. So p divides yz. Now, since p is a prime number and p divides yz means p either divides y or p divides z. Alright? So, but that would contradict with the assumption that xyz are pairwise coprime. So in either case, p would be common factor of x with y or x with z. Alright, that's contradiction. So which means they're coprime. So what do we have? We have this expression here. I'm going to rewrite it in the n, and this term here, xyz, and denominator is coprime, right? So which means in order to n to be an integer, xy, yz, and zx has to equal a factor of 2023, but we claim that it has to equal 2023 because if the factor here could be 17, could be 119, things like that. But if it's not 2023 is a factor, then n would contain a common factor with 2023. We also assume 2023 and n is coprime, so which means the denominator is 2023. Okay, so with that, since this number is limited and x is the smallest, you can just enumerate, try out different numbers and try to figure out what is. There are multiple solutions, but we're looking for the n. In this case, it's going to be xyz is the smallest. We want xyz to be smallest, right? So if you write a small program, you can do that, and the answer is actually 15, where x equal to 1, y equal to 3, z equal 5 for 5. Okay, for other solutions, this multiplication would be larger. Okay, there are multiple solutions to this equation here, but we're looking for the smallest n. So that's the answer here. All right. Okay, so this is the solution and just another 2023 challenges. I have some other video. Do check it out. I have the link in the description. In the meantime, please like, share, and subscribe to the channel.